Hi friends, welcome to TechieMit. So in today's video we'll cover a new topic on semaphore. So in continuation of the last time PPT we have seen. So let's deep dive into the real topic of counting semaphore and binary semaphore. So let's see with example. So what I will do, so I will create a semaphore, a binary semaphore instance. Uh, as you know, binary semaphore is having only one object. We will have one, and we have a semaphore called as counting semaphore. New semaphore, counting semaphore. We will import this, and we'll print this out over here. Starting binary semaphore threads, and yeah. So what we'll do, we'll start over the thread server. We will make the use of Lambda over here. So yeah, for that we'll take a for loop. I will iterate it over almost 4 times, and I'll take a current thread instance equal to I, and I will take the lambda over here. Now over here we need to give the call to the simulateSemaphore method. We'll have the semaphore as the instance, and you have created either it's a binary semaphore. Pass it the binary semaphore, we'll pass it the type over here, binary semaphore, and pass the current thread instance to get to know what is the current thread instance. So we'll pass create. So this will create the method. It will have a parameter binary like semaphore. You can have either a binary or yeah. So it's complaining this. So what we'll do? Can we make it static? Yeah. So it's complaining regarding this. So we'll just take it into the loop, and so it will iterate inside the loop. Otherwise, we can take it over here. Static current thread instance. Okay. And equal to high. Okay, I've taken it in the global level, current thread instance, and similarly we'll have one more for loop for the counting semaphore. So we'll take a similar just to see what time starting counting semaphore threads, and we'll pass over here counting semaphore, and over here the counting semaphore object. Now here the main logic lies of handling over here. So yeah, simulate semaphore. So we'll make the use of try acquire method. So we'll take as permit this method. Yeah. we'll have a sys out over here. Trying to acquire permit. Number of available permits /t Semaphore dot available permits. Yeah, so we'll take this in the try thread dot sleep. We'll introduce a delay of 2 seconds, and we'll introduce a catch over here. Interrupted exception ex the when stack trace, and we'll also have finally to release the acquired permit. So just take this over here to save our time. Type release the permit. Release permit, and yeah, we'll have the semaphore.release method used over here because it was trying to acquire available permits. So after releasing the permit, what are the number of available permits? It will check on that, and yeah. So to this will what if means there will be negative channel? What if means if there is a thread and you are not able to acquire it? So for that it will have a negative signal. We will handle in the else. So that particular thread is not able to acquire. It will have only a sysout statement. So like type fail to acquire permit. Let's see. And because every time you will not be if you try to invoke and you will not be able to acquire that, it should fail to acquire. So that channel should also be covered. So we have taken that Semaphore permits. This is the F scenario, this is the else. Simulate. I think so. We have so in build the logic. So we create a binary semaphore. We are going to counting semaphore, and in the above current instance, we will call to the new using Lambda. We will call to the simulateSemaphore. We pass in the binary semaphore, and we will pass it the counting semaphore, and we have first try to acquire this permit and check when say introducing a delay. Then we have to trying to release the semaphore, and if it's not fair, trying to covering the failed permit scenario handle names block. So I think so we are good to go and execute the code. Now let's see in the console. Clear this. Don't forget to execute the start method over here, and so start method over here, and now again we'll compile the code. See, now it's compiled and is executed correctly. So first, what is printed? Starting binary semaphore thread. So first it printed binary, so starting binary semaphore because we have first executed created this instance. And after that, binary semaphore failed to acquire permit, number of permit able to 0, and semaphore trying to acquire permit, number of available permit 0, and semaphore failed to acquire permit, number of available permit 0. Starting counting semaphore binary acquire permit, number of trying to acquire permit, this is 3, after that 2, after that 1. As a binary semaphore release permit, number of available permit was 1, because 1 was acquired and 1 was released. I think so we should just change the line we're trying to acquire. We'll just print as acquired thread. So it should make more sense. So we'll just take it as acquired permit, and we'll just compile the code. Yeah, so starting binary semaphore threads, binary semaphore failed to acquire permit, number of available permit 0, binary semaphore acquired permit. So yeah, once it was able to successfully acquire the permit, and after that, because it's only one instance, so after that number of available permit so it will be 0, correct. So that is correct. Finally, after that it printed binary semaphore failed to acquire permit, number of available permit 0, and after that it we started with the counting semaphore. So binary semaphore will again it will try to iterate through the loop. It will print as it will not able to acquire because it will because there is no instance that it can acquire, so it will go in the failed loop. So it is going to fail to acquire permit, and so after that counting semaphore acquired permit, number of there was 4, it goes down to 3, after then 2, after then 1, after then 0, and after all this execution, then binary semaphore release its permit, number of available permit was 1. Then counting semaphore release its permit. So release permit. So number of available permits were from 1 to 4. So ultimately they went up to 4 because 4 were acquired and 4 were released. So if you change the number over here, so like I change 5 over here, and I change 5 over here. So currently it will the count will increase or decrease accordingly. See, yeah. So 1, 3, 4, 5. So yeah. So in that also, binary binary semaphore was able to acquire the permit only acquired permit C. Binary semaphore acquired permit only once, and rest of the time counting semaphore acquired the permit of acquired permit 4310. Ultimately, when the count went on 0, after that binary semaphore finally released it acquired permit, and after that the counting semaphore one by one release all the permits. So after 5 counts, it released all the five permits. So it's like first the threads enter the loop, it check if it acquires the permit, it does its execution, after that it releases it, and depending on the number of thread, whether it be 4 or 5, it will acquire the permit, and it will do its execution and release the critical section in the semaphore. So this is basically how the working goes of semaphore. So with the help of simple example and through simulation, we saw and simulate semaphore method useful utility. We saw how the working goes about the binary semaphore and counting semaphore, and we saw a real world example of it. And hope so you all might be like it. So do keep liking, subscribing to #TechieMit. More to come on you other further multi-threading related topics. And bye for now.